In this video, we will show how to create an IRPM model. After having calibrated a rock physics model to, for example, a well log, we need to add uncertainty to that model. This is done by specifying probability density functions to parameters we are uncertain about. So start by opening the model library and choose the rock physics model that you have calibrated. The first thing that you want to do is to go in and save the model as a new model so that you keep your calibrated model unchanged and you get this new model with the uncertainties in it. So click the Save as New Model. Then, for example, for the pore pressure, you go and change the value to distribution. This provides you some more parameters you can specify for this property. If you push the plot button, you plot the probability density function. So what is a probability density function? The plot that you see here is the relative likelihood. And if you integrate, so calculate the area under the graph within a certain interval, you calculate the probability of the property having a value within that interval. A probability density function, or PDF, can be defined by a mean value and a standard deviation. And the probability for the property having a value within the range of the mean value plus minus the standard deviation is equal to 68.27%. In addition to specifying the mean value and the standard deviation, we also can specify an absolute minimum and maximum value for this property. Note that you can also here use the unit converter when specifying the parameter values. We see here some examples of the effect of changing the minimum and maximum values. In the following modeling, we will assume that the effective pressure is the same as the pore pressure. So we don't want to define a new PDF for the effective pressure, even using the same specifications as we did for the pore pressure, because then they might be unequal in a given forward model. Instead, we choose to change the value here to parameter, and then when we select the pore pressure over here, we say that the effective pressure is going to be the same as the pore pressure. Then we proceed by defining the distribution for the temperature. And jumping to the overview, we see that we have a fair amount of parameters that we need to specify. So let's just save this model for now. And then we cheat a little bit and we jump over to a model where I have already specified all the parameters. So here you can see the model we just worked on, and here we see the one that I have prepared in advance. So I open that and I jump to the overview. And we can see here that I have assigned distribution functions for various parameters that I am unsure about. Except for the porosity, volume fraction of shale, and saturation, because those are the parameters that I want to predict in the inversion. So they are a different set of parameters. Before we went into the data model over here, now we are going to work with generating an IRPM model. But before we do that, we want to specify how many iterations we want in the Monte Carlo simulation, for example 50, and we can also make specifications about the parallel processing. Now, proceed into the IRPM model, and we can give it a name. And then we want to specify the free parameters. And by that we mean the parameters that we want to predict. So the effective porosity should be somewhere between 0 and 0.4, the volume fraction of shale between 0 and 1, and the water saturation between 0 and 1. And then we just hit the run button, and this will do the forward modeling, creating those model constraint cubes, or the IRPM model. These are theoretical model spaces giving a relation between certain values, so for example the density, velocity, and so on, and the effective porosity, volume fraction of shale, and water saturation. In case of some rock physics model, this might take a little bit of time, but here we are done, and we can also look here in the report that we had going, a summary of the details. So this first slide is a little bit long. If we split it on 2 slides to see. Then the first slide gives us some description of the model, and then we have here some specification of the IRPM model that we have generated. And finally there is the specification of the model properties with their distribution functions. This concludes generating the IRPM model, and the next step will be to do the inversion.